My name is Christian. For people who don't know me, I'm one of the VFS maintainers nowadays. So I work a lot on the kernel. I do a lot of user space, low-level stuff, not so much in recent times because of the lack of time. And I want to introduce the new mount API to you, where new is kind of a stretch because it's been around for a couple of years, but we don't have any documentation for it, which means nobody knows about it for real, unless they really make an effort to learn about it. And so this is a short notice talk. I'm replacing someone who couldn't make it, unfortunately. So I don't have demos, which I usually do. So you will have to listen to me talk a lot. So I don't know, most people will be familiar with the old mount API. Oh, and by the way, if you have any questions during the talk, let's do it right away. And we'll see where we end up time-wise. Most people will remember the old mount API, I assume, which is just a single system call. It's a multiplexer because it combines a lot of different things. I mean, the first one, what does it do? Creates a new file system mount, so it really creates a new Superblock, a new X4 file system. The second one creates a bind mount, which is a totally different operation because it already exists, that the file system already exists. The third one changes the mount property of a single mount. And the fourth one changes the mount property of the Superblock itself. So there's a lot of different stuff going on, like very lumped together. And has a couple of drawbacks. It's purely path-based. Nowadays, we try to make most APIs that we add to the kernel be file descriptor-based. It's just way nicer for delegation, for safety in general. You can have scoped operations that you always start from a well-known starting point. So it has a couple of advantages. And path-based APIs nowadays, we mostly avoid them. Like usually we either do stuff like OpenAdd, where you have an FD and then you have a path component, or we make them purely FD-based. As I mentioned before, this mixes Superblock with per mount operations. The old mount API does. It also changes mount properties in a way such that it isn't idempotent. So depending on how you do it, you can change mount properties with the same mount call in different ways. It doesn't support private references to mounts. There is an approximation to this. So by private references, what I usually mean is you don't have any entry in the file system hierarchy, so you can only refer to the mount via a specific FD. You can do this in the old mount API, but you have to create the mount first, attach it to the file system, and then unmount it, and then you have a private reference if you have kept an FD to that mount open. And it doesn't support delegation. So you can't, for example, mount across namespaces. The kernel will outright block this, tell you, no, this doesn't work. Oh yeah, the first comment that I made, purely path-based, you can work around this. I mean, most people who have worked with mount have sort of by necessity needed to figure this out. You can mount through proc self FD number. That's usually how you get around this restriction, but it's really not that nice, and it also still doesn't allow you to do delegation. And so we have a new mount API that's been developed for quite a while. I think it got merged in, like, I don't know, 5.11, 5.10, maybe before that. I don't exactly remember. But it's been around for a while, and user space hasn't really switched over to it. And by that, I mean for a long time, libmount hasn't supported the new mount API. This only, I think Carol merged this for the last kernel, with the last kernel release 6.5 or 6.4, we finally got full mount API support with libmount, which is a big portion of user space mount usage. We have made use of it in low-level user space projects such as LXC, because we wanted to make use of features that don't exist in the old mount APIs, such as ID-mapped mounts. Systemd has adopted it fairly quickly for security reasons, but also for ID-mapped mounts. but a lot of the properties weren't really known. Like a lot of my time was spent when people came to me with questions explaining to them how this all works, what limitations exist, and so on. And this is on us. We don't have man pages when this got merged. We only have a really detailed man page for the mount set other system call, which we will cover in a second. We don't have it for all of the other ones. We should really catch up there. Yeah, so the new mount API has all of the features that were missing in the old mount API, in my opinion. So it separates Superblock operations from per mount operations. It also separates Superblock and per mount properties. So what I mentioned before, depending on the type of flag operation, for example, in the old mount API, you can make the Superblock read-only, which makes all of the mounts read-only across the system, or you can make a single mount read-only, which means that only this specific mount, not the file system, is read-only, and it's easy to mix this up. It also has other limitations. For example, one thing that I didn't mention is you can't apply mount properties recursively, so to a whole mount tree easily. Like you can't, for example, do ms remount, ms read only, and it applies to the whole mount tree. It always will only mount the topmost mount read only, which is very unintuitive for user space. Has, for example, caused a CVE for Docker a few years ago. And it supports true private references so that you can create mounts that don't exist anywhere in the file system hierarchy. Another way of saying this is they're not visible in any mount namespace, and you can still interact with them. And it supports delegation, which is also something that systemd is currently already making use of. So it's a bunch of system calls. fsopen, fsconfig, fsmount, movemount, opentree, mount setother, and fspic. Have most people heard of these system calls already? Oh, that's surprisingly few. So these all exist. I mean, all of the systemd folks and maintainers and so on, I'm pretty sure that, and you obviously must know about them as well, because Strace happily decodes them, which is very nice. So this is the whole mount API, the current state of the mount API, the ... We will come to this portion at the end of the talk, time permitting. And I'm going to cover the system calls, and I'm going to try to explain how you create mounts with the new mount API and what advantages it has over the new, over the old mount API. So fsopen creates a new file system context. That is a fancy way of saying it's just an internal kernel object that carries state associated with a file system. So it's just an abstract handle. This FD doesn't allow you to do anything. You can't open files. You can't interact with the file system in any way. It's just really there to like have some sort of state that you can interact with. And the first interesting system call, well, really interesting system call, is the fsconfig system call. This is, again, unfortunately a multiplexer, but it's something that we are very used to in the kernel, apparently, and we can't live without them. It's the new way of how you set mount properties on a file system-wide basis or on a Superblock basis, though at this point in time, the only thing that you have is this abstract file system context. It has various options. The new mount API lumped everything together in terms of you only had string options that you said. It didn't have a clear way of passing binary information and so on. It was very hacky if you wanted to pass file descriptors as a file system property, like some file systems take file descriptor references and so on. In the first example you see, this is a way of setting a string property. So you see a clear key value mechanism source, and then the source in this case is def SDA2. It's a limitation I will address in a second. The second one is a flag, in this case no ACL, which would turn off ACL depending whether or not the file system supports this mount option. And the last one is a way to also set file descriptors, which is currently not very actively used because I think a lot of file system developers themselves have not fully, I mean most file systems have, well, most file systems is strong, but a lot of file systems have been converted over. The new mount API allows you to do a lot of nice things with setting up properties and mount properties that currently file systems don't really fully make use of API-wise. So hopefully this will change in the future. You can do a lot more. There is like binary, so you can set blobs, you can also have paths, and there's a bunch of stuff. The main thing here is that it's always associated with all of the file system. It's not associated with a specific mount. At this point in time, no mount even exists. And two separate operations that are very crucial are fsconfig command create and fsconfig command create exclusive. This is the step where you turn the abstract file system handle, you create a superblock, more or less. So in the old mount API, what happens from a user space perspective is you turn a magic set of options into a file system reference that is attached and visible in the file system hierarchy that you can interact with, and that's done. But in the kernel, conceptually it's very different. Like there is a stage where you just create like the file system context where you set all of the options on it, then later you create a superblock, and then later on you create a mount, the first mount for this superblock, and sort of part of this internal state is now also represented in the API. So fsconfig command create creates a superblock, which is a file system context. I mean, if you have any questions around this, you should ask me now. Otherwise, I will just assume you know what this is. Fsconfig command create has the exact same behavior as the old mount API had. So let's say I have created an X4 file system on my dev SDA device, and I have used the old legacy mount system call and mounted it at /mount. So somebody else later comes along and decides, oh, I want to mount the X4 file system that is on /dev SDA4 /SDA, but I want different mount options. I, for example, want this without POSIX ACLs. I want different device options and so on associated with it. So you pass all that through, and the kernel seemingly creates a mount for you at a different location. Did you get a new superblock, or did you get the same superblock? You did get the same superblock, which also means that all of the mount options that you requested were completely ignored. And there is no trivial way to find this out. I mean, you can check your mount, you can check whether it's been actually mounted with our ACL support and so on, but the kernel will just happily recycle superblocks. It's just been like that for a very long time, back probably Linux 0.99, I don't know. It's just very legacy behavior, and we kind of carried this behavior into the new mount API, and I think it was done explicitly so that you could emulate the legacy mount behavior with the new mount API. That sort of was the ideal. Realistically, what happens in user space that we find so many quirks where the new mount API differs from the old mount API, that fully emulating the old mount API through the new mount API, maybe, maybe not. We try to fix these shortcomings so that this will remain possible, but I don't personally consider it a high priority. It's a new API. We should rectify a bunch of mistakes that we made in the old API. So I wanted to get rid of this problem for a long time because it annoys me to no end. Essentially, you get a bind mount. Every time you think you're requesting a new file system mount and that superblock already exists, the kernel will happily create a new bind mount for you, and you will never find out when you when you requested new superblock options. So this is why, starting in kernel 6.6, we added fsconfig command create exclusive, which prevents superblock reuse. So when you use the new mount API and the file system supports the new mount API, the kernel will notify you, oh, this has already been mounted, I'm not recycling this. So you can find out, okay, somebody has already mounted this file system somewhere else. This works for most file systems. I mean, it's mostly interesting for block-based file systems, so ext4, XFS, what have you. For other file systems like tempfs or I don't know, devpts, where every mount is a new instance anyway. You never recycle the superblock that exists. This is basically an op. But for block-based file systems, this is very much important. And NFS4 is kind of special because NFS4, or NFS is in general very special. But if you try to mount an NFS file system, because of the way it works, it will internally constantly create superblocks. So if you request a mount for an NFS export for /A/B/C/D/E, then for each path lookup, it will create a new superblock, which is just kept around for the duration of this path lookup. Just the way how NFS works. So for NFS, it really doesn't give you a lot. Maybe we can figure something out there in the future, but also NFS. And then FS mount. This is the another interesting step. So now we have set a bunch of file system options, and we have created a superblock internally already, and now we want to have a mount for this superblock, which is the point in time where you can actually start interacting with this object in user space in a meaningful way. So this system call creates a mount for the superblock. And it returns you an OPAF-like file descriptor. Everybody familiar with an OPAF-like file descriptor? Okay, OPAF, so usually you have file descriptors that allow you to do a bunch of stuff. Like, for example, you can read files, you can write to files, and so on. And OPAF was once thought to be an opaque handle where you can do stuff like shadir, or you can use it as part of an open-add call, so open other files within the file system, but you can't write or read files, and so on. So it's a very limited sort of type of file descriptor. Realistically, nowadays, you can do stuff like setx adders and so on, which is kind of weird and probably not by design, but ideally it's like a handle that you can easier share between processes without the danger of another process being able to read or write. Realistically, there's also a bunch of loopholes because you can always use proc to reopen a file. So if you have proc pid fd and then the number of your OPAF file descriptor, you can call open on this, and then you get a new handle to this file, and then you can reopen the file with read-write permissions or read permissions. This is a hole that we're trying to fix with an extension to the open-add2 system call and a whole separate topic. But in general, it's supposed to be an opaque handle which has limited abilities of what you can do with it. And the file descriptor that we pass in, the file descriptor for the file system context becomes unusable, so you always get ebusy from now on. You can just close it and get rid of it. And this mount FD refers to an anonymous mount and is a private reference on the file system. What I mean by anonymous mount, usually each mount that you create, especially with the old mount API, belongs to a mount namespace. And once it has been attached to a mount namespace, it will never change its association with that mount namespace. So you can't move a mount between different mount namespaces. It stays fixed for the lifetime of the mount. So it becomes like once you make a mount visible in the file system hierarchy, you commit to it belonging to this specific mount namespace. Would be pretty difficult to get, like, it has internal implementation details of why this is a good way to do. A good way to do it. It would be rather complicated. The tree hierarchies that we have to take care of and so on would be very hard to get right if you could just move mounts around. And it's also easier to reason about. But in this case, we're dealing with a special type of mount. We're dealing with what we call an anonymous mount. An anonymous mount doesn't have any type of mount namespace attached to it because it's never been made visible in the file system hierarchy. It's an opaque handle. So anonymous mount namespace, in the sense, it's not visible in the file system hierarchy. And it's a private reference for the same reason. It doesn't appear anywhere in the file system hierarchy. It doesn't belong to any mount namespace. So you can keep this FD for yourself and then have your private tempfs reference, for example, that you don't share with anyone else. If you close it and you're the only one holding an FD open, then the file system goes away. This is a pretty nice property. Usually what people used to do is they created a tempfs mount at some random location, probably a randomly created directory. They opened a file descriptor to the directory and then unmounted lazily this directory, and then they had a private handle on, for example, a tempfs mount. But this is now built into the mount API proper that you can actually do this. Oh yeah, and you can specify per mount properties, mount adder, no exec in this example. And if I can do this here, let me see. If we can go back here, So this is a mount property, what I wanted to say. Mount adder no exec only applies to the mount. And before I promised you it's clearly distinguishable from properties that you set on a file system wide basis, so on a Superblock basis. So the fsconfig system call can, for example, be used to specify file system wide options. Currently we don't support a lot of Superblock wide options. The most obvious one is RO, so read only. Old mount API flashback. In the old mount API, if you created a new file system mount and you specified MS read only, then the kernel just interpreted it because it was inherently ambiguous, because Superblock and a mount for that Superblock were lumped together as a concept. The kernel was like, what do you want to have made read only, the file system or this mount that I created for this file system? I don't know, so I'll do both. So it made the file system read only and it made the mount read only. And if you created a bind mount, everything was read only because the Superblock was read only. So you can see there is an inherent ambiguity here. And here, this is just a property that applies to a single mount. So mount adder no exec or mount adder read only applies to this specific mount. And if you want to make the Superblock read only, you have to do stuff like, this is why I went back earlier, but I apparently deleted this example. You can use fsconfig, fdfs, fsconfig set flag, and then instead of no ACL, you use RO. This will turn the Superblock read only. This is a VFS level change, so it doesn't go into the file system. The file system doesn't need support for it. It's just that the VFS is turning the whole Superblock read only, but it doesn't turn the mount that you create for it read only. And
so it's about a read-write mount of a read-only Superblock?
Sorry?
A read-write mount of a read-only Superblock. How does this work?
A read-only?
A read-write.
Oh no, it doesn't work. I skipped over this because it was just words, but I mean, obviously, if you make the Superblock read-only, you imply that the mount is read-only as well. You can't have a read-write mount and the read-only Superblock. But if you turn the Superblock read-write again, then the mount becomes read-write. But if you, for example, have the Superblock read-only and the mount read-only, and you turn the Superblock read-write, then the mount obviously stays read-only. Okay. FS mount. And last but not least, obviously, the step that is missing, we have a private reference to a mount, we have an anonymous mount, but it's not visible in the file system hierarchy. For most use cases, you obviously want to have this mount that you just created, or the file system mount, to be visible in some mount namespace in the file system hierarchy so that other users can access it. And this is where the move mount system call comes into play. You take the mount FD that you just created earlier, you specify a source path and a target path. Again, it's all file descriptor based. In this case, we request that the final path component may not be a symlink for the from and target, for the source and the target. Or if you don't need any subpaths, then you can just use move mount with move mount empty path, and then it will just operate directly on the file descriptor. So what this thing allows you to do is attach actually the mount that you just created in a specific mount namespace. Okay, so I have a compressed example, hopefully. So what we covered until now is you create a new file system context. In this case, the example is XFS. You set the source for that file system context, which in this case is def SDA, which is required. For some file systems, you obviously don't need it. For a tempfs file systems, you don't need a source. For a def PTS file system, you don't need a source. So that's specific to what type of file system that you're mounting. And then you set a VFS level property. In this case, we make this file system context read-only. And then we create an exclusive Superblock. So we want to make sure that we actually did create the Superblock and call fsconfig command create exclusive. And then we call fsmount. turn this Superblock into a mount FD, then we can close the file system context, and then we can attach the mount that we just created to the file system. And this is what goes on more or less behind a single mount system call. Obviously, if you just want to quickly mount something, and you can do with the old mount API, this will stay around, this will stay supported, you can obviously do this. New features, new fancy features that we do, we can mostly only do with the new mount API, and then it makes sense to use it. Mounting usually doesn't necessarily have to be very fast, so it's a bunch of system calls. But obviously, we're missing a bunch. So far, I only showed you how to create a file system mount, but I didn't show you how to create bind mounts. Yeah, Dimitri?
That file descriptor is not a valid descriptor, right?
ebedf, no.
Yeah.
Oh, sorry, that's my convention. I'm confusing people, and I think I infected systemd with this as well over time. When I, in all my code in user space, I usually pass minus ebedf instead of -1, just to have a visual signifier that it's a invalid file descriptor. It's not necessary, that's just, I do this unconsciously, sorry about that. But yes, it's an invalid file descriptor, but the path is absolute, so should be fine. What is missing is bind mounts, which is usually a very important concept as soon as it comes to, when it comes to containers, and in general systemd services and so on. For that we have the OpenTree system call. So OpenTree also has a bunch of functionality. It opens a file descriptor that refers to a mount. The first one, OpenTree cloexec, only gives you a cloexec file descriptor. I once lobbied to make the whole new mount API cloexec by default. We didn't, for whatever reason. So we have like all of these flags, OpenTree cloexec and so on, fine. And then OpenTree clone lets you create an anonymous mount. So in a sense, this is equivalent to what you would get from an fsmount call. An fsmount file descriptor is a reference to an anonymous mount. What it does here is internally it copies an existing mount. It creates a full copy and gives you an anonymous mount back, so not attached to any mount namespace that you can interact with. And it also has support for doing this recursively, so you can copy or clone a whole mount tree. You can get a whole private reference to a mount tree through OpenTree clone. It's not attached anywhere. This file descriptor is, again, OPAF-like, is an OPAF file descriptor, and you can use this with the move mount system call like we did before. Obviously, the main reason being here that you want to attach it to the file system hierarchy or to a mount namespace somewhere. There is a limitation here. If you can specify an OpenTree file descriptor as the source to create another OpenTree file descriptor. This has a lot of permission checking limitations. For example, permission checking usually involves looking at the mount namespace of the mount and the user namespace that this mount is owned by, and then checking whether you are capsys admin in the owning user namespace of the mount namespace. If you have questions around namespaces, feel free. I'm happy to explain this as well. Because it's an anonymous mount namespace, we can't easily do the permission checking because we don't know where this anonymous mount namespace originated from. We could probably keep track of this. I'm not sure, because I haven't really thought about this in detail, if we have any other limitations, but currently you can't clone an anonymous mount. You also can't mount on top of an anonymous mount namespace for the same reason. Permission checking and tree hierarchy would be very wonky. Yes?
But if you OpenTree clone and then you move mount it into a namespace, can you clone it then?
Yes. Once it's been attached to the file system hierarchy, you have all the permission bits in place. Alban?
If you don't give the flag of OpenTree clone, then is it equivalent to open with OPAF?
Yeah, essentially. Yep. I'm trying to remember. It would probably fail. It should fail with einval if you specify something that is not a mount point. That is not the root of a mount. I'm pretty sure. Is that, you know what I mean? If FD DFD and then I look up mount and that mount is not a mount point, then I think it should give you einval. Because it's like only supposed to open, you're supposed to refer to an actual mount that you want to interact with, in contrast to openadd, which would work on any directory that isn't a mount point. I should probably also mention, because I forgot this, I've added an extension to the move mount system call that allows you to mount beneath another mount, which allows you to atomically replace mounts. That's a new extension in v6.5 that I forgot to mention. If you have questions about this, we can cover this as well. And last but not least, we have the mount set adder system call, which I added for 5.12, I believe. This is a way to change properties of a mount, because currently we were lacking this ability. So it works the same way. You specify a file descriptor that refers to a mount. You can apply mount properties recursively, which you see right here at recursive. It's idempotent, so specifying the same set of options to set and options to clear will always give you the same set of mount properties. You can clear and set mount properties at the same time. There was another wonkiness in the old mount API, like, for example, let's say you had a bind mount that was no exec, no suid, but read-write. And now you wanted to go to a read-only mount, so you specified MS read-only, but none of the other flags. Then the kernel would internally clear no exec and no suid for you. So you ended up with a read-only mount, but with suid binaries and the exec property. Kernel just did this because, like, YOLO. I don't know. Just the way it worked. And so we desperately wanted to get rid of this. So we differentiated between adder set and adder clear. And adder set will only set mount properties, but not change any of the existing mount properties. Adder clear would only clear mount properties, but not set any other mount properties. And you can obviously specify mount options to set and mount options to clear. If I remember it correctly, how did I implement this? It either clears first and then sets, or it sets and clears first. I need to look into the kernel sources, but I have written the detailed man pages where this is explained, in what order the kernel actually does it. Propagation allows you to change mount propagation, which is a whole other can of worms, which I didn't cover. But essentially in the old mount API, this functions as an enum, so you can't, mount propagation has stuff like a shared mount, a private mount, or a, sorry for the terminology, slave mount. And a mount can't be shared and private. A mount can be shared and slave, but you can't set multiple propagation options at the same time. So they're effectively an enum. In the new mount API, we treat it as a proper enum. We don't lump it together with the other flag options. And last but not least, since kernel 5.12 as well, you can create ID map mount, which is the ability to attach a user namespace to a mount, which determines the ID mapping that is supposed to be used for that mount, which, for example, makes it possible to share your home directory in a container without recursively choning file ownership, and so on. So it's a very nice property. You can also do this file system-wide. You don't... So another topic, I have examples for this as well, but I'm pretty sure we're not going to be able to cover this today. So here's an example for how to create an ID map bind mount. You call opentree. Again, the ebadf, ignore it. It just means it's an invalid file descriptor and it's supposed to operate on an absolute path. Opentree clone will mean it creates a clone of the existing mount. Actually, this should work on any directory, opentree clone, so it doesn't have to be a mount point. If /mount isn't a mount point, then in this case, because you specify opentree clone, it will copy this into a new mount. And then we specify a user NS that we want to have attached to that mount, and then we specify mount adder no suid, which means we don't want any suid binaries on this mount, and then we call it, and then we move this mount and attach it to /opt in the file system hierarchy. This is how you would create a bind mount with the new mount API. I'm skipping over how to change properties of a superblock. Therefore, we have another separate system called fspick, which allows you to pick an existing superblock, and then it's effectively the same sort of dance with changing mount properties that we had for creating an initial superblock. But I have examples for this as well if you're interested. You can probably append them to the slides. And last but not least, this is something that I promised. Thank you. Let me quickly go over this. One nice property we have is delegating a mount. This wasn't possible in the old mount API. By this, I mean you have one process create a file system context and another one attach it somewhere in another mount namespace or container. It doesn't work in the old mount API. This works in the new mount API. Systemd nowadays makes use of this, or at least the pull request for this is up. But essentially, there are only so many steps that require privilege. So if you know that your file system context creates privilege to be created, the superblock to be created, you can split this out into a privileged process, for example. So fsopen, you call it as an unprivileged user. You need to be root in your user namespace. By unprivileged, I mean root in a container can use this call. fsconfig set string, you set the source property, and the only privileged step that is read here is fsconfig command create exclusive, which creates the superblock, because that's the time when the kernel will check, do you have permissions to create this superblock, because this is a sensitive operation. Now the kernel, the file system might start to pass the superblock that is stored on disk. So at this time, a crafted malicious image might be able to attack you. So this needs to be a privileged operations for most file system. Then fsmount, again, can be called by an unprivileged user, provided they have the necessary permissions on the root of the file system. And then, for example, you can change your user namespace, you can change your mount namespace. Because this refers to an anonymous mount, the kernel will just verify, do you have permissions over the mount namespace that you're currently trying to attach to, and then it will attach this mount to the file system hierarchy, which means you could have a privileged helper like systemd nowadays does that creates a file system context for an XFS file system, mounts it for you, hands it off to a container, and the container can attach it anywhere it wants to in the file system. Together with ID mappings, that obviously means you can make use of file system mounts in containers, provided you subscribe to the systemd model of creating mounts for you. So this is the very powerful mechanism that wasn't available in the new mount API, and very crucial for container runtimes nowadays. And there's a bunch of new things that you can also ask me about that we want to have in the future. And with that, I am open for questions. Yes?
In the previous slide about NFS, if you want to use a user namespace specific for NFS, but on the Superblock level, can you do?
For NFS?
Yes.
Oh God, now I'm being asked about NFS. NFS should work the same way. The thing is, NFS is kind of wonky because it also picks up additional mount properties like the network namespace and so on, and it does that based on who calls fsopen, I believe. I would need to look. So the problem is that you can technically, the mount API, new mount API, technically allows you to call each of those functions in a different namespace, which can get hairy pretty quickly. I fixed some bugs in there recently for Tempfs that were reported to me because of the file system wasn't prepared to deal with that. So if you can call fsopen in the target user and network namespace that you want to use, and then create the superblock and then attach it, it could probably work. So you need to call it from the correct network namespace. NFS is really, I would really need to look at the code to be able to make a definitive statement of how that would actually work, because this is a very special file system. Yes?
I might have just missed something, but if open, how do you make a bind mount of just a regular directory to a regular directory that say open tree will return eval if it's not?
No, that's, sorry, I tried to stress this, but I wasn't clear enough. The open tree clone flag is the important part here. If you don't use open tree clone, then it will require that it's an existing mount point. If you use open tree clone, it will take any directory and turn it into the root of a new mount. Yes?
Okay. Is this API feature complete, or do you think about adding even more system calls?
Yes. So we need more system calls because what we lack currently and what user space desperately wants is a way to query for file system and mount information. We have no easy way of doing this. Like, for example, what systemd keeps bugging me about is the ability to specify a mount and then get all of the child mounts of that mount. We have no way of figuring this out currently nicely. You can't easily query a mount point for all kinds of mount properties that are set on it. I mean, you can always read proc1 mount info, but especially if you have a lot of mounts coming and going away, if you have a lot of mounts coming and go away, it gets racy very quickly, and it gets very inefficient if you have to poll on proc1 mount info. So this is definitely something that we need to fix, but it's a long upstream battle because everyone has really strong opinions on how this API should look like. But we had a meeting at LSFMM this May, and we came to an agreement. Whether or not that agreement still holds when patches hit the list is a different topic.
You're mentioning directly make mounts. I'm curious about what is your back plans to tackle this.
To what, to?
To tackle direct image mounts, which I suppose are to build images or.
I think we need to wrap up, but I'll answer you in a second. Sorry. Thanks.
Thank you.